Okay, let's talk about graphs, tables, and functions. This is the last lesson in the domain and overall, so be sure to pay attention. Graphs are all over the test, and a lot of questions use graphs to illustrate other problems, or you're going to have to solve problems using equations by looking at graphs. So let's look at some of them. These aren't the coordinate grid style of graph. They're column and bar graphs, line graphs, pie graphs. You do not need to know the names of the graphs, but you need to know how they work and what they do. So the slope's the rate of increase or decrease. When you see a graph, estimating. That's really important. If you can estimate and not have to solve something, that's great. Slope determines the rate of change. Flat, like remember that trick question we talked about, is no change. Decreasing is down, increasing is up. Okay, so let's evaluate a graph or chart. I'll give you a brief look at this one. We'll also have it on the next page. This is a column graph or bar graph. Okay, so when were the most what's it sold? What quarter? You'll see on the far right is the key, which shows which color corresponds to which item. The what's its are light blue, the doohickeys are medium blue, the widgets are dark blue. When was the greatest decrease in doohickeys? Decrease would be when they went down, not necessarily the lowest number, but over which quarter was the greatest decrease in doohickeys. If you'd like, at any time, you could pause the video by pressing pause or by tapping on your mobile device. I'll give you a second to do that. Okay, we're back. So quarter 4 had the most what's it sold. The greatest decrease in doohickeys was quarter 3 because the number of doohickeys went from 4 to 2. 4 minus 2 is 2. Okay, let's look at value and rate of change. Which has the greatest value? Which has the greatest rate of change in value? We're just going to go through this together. Okay, so C, if we look at line C, that starts with the highest value at 5,000. It also decreases the most. You can tell that from the negative slope. It's going down. So that by 0.3, it's at 0. So that's a huge rate of change in value. If you notice, the slope of that is it's like going straight down. So C starts with the highest, C decreases the most in terms of slope, D starts and finishes fairly high. You see that? It starts above 4,000, finishes even higher. So that increases. B is straight, so there's no change. It starts at 3,000, it ends at 3,000. So it has a slope of 0. A has the highest rate of change, okay, because it's going up. It has the greatest increase, the greatest rate of change in value, okay, because you look, it starts at 0, it goes up, it hits nearly 3,000. Reading a line graph. Okay, the x-axis is across or horizontal, the y-axis is up or down, the apex is the highest point. Read the labels. They're there for a reason. These line graphs are often integrated with other content. So here's a line graph. You can take a quick look at this, and don't worry, I'll have it on the next slide with the question. All right, so the following is a graph for a toy rocket. At what height in meters was the rocket released? What was the highest it reached? How many seconds until it landed? About how high was it at 2 seconds? How about 3 seconds? I'll give you a moment if you want to pause this. Okay, we're back. So the height in meters it was released at was 2.75. Look at the 0 value. Okay, that's the time, and the height at 0 is 2.75. The highest it reached, find the high point on the graph. It was 3.25. It's at about 2 seconds or so. How many seconds until it landed? This is a little tricky. What do they mean by landed? That means it hits 0. So at what value did it hit 0? It's a little tough to tell here, but we can tell it's in between 2 and 4. On the earlier graph, we could tell it's at exactly 3. Sometimes you will have to estimate. So take a look at it, and you could see it's about 3. About how high was it at 2 seconds? If we look at 2 and we go straight up, 2 seconds is on the x-axis, the seconds is on the x-axis, the time, and you go straight up about 3 meters. At 3 seconds, it was 0. Okay, now we're going to look at a pie graph. If Becky works 40 hours, how many of those hours would be on-site technical support according to this graph? Okay, now let's look at this graph. Documentation, 1/4. Help desk, 5 out of 8. On-site technical support, 1 out of 8. Remember, you could pause at any time by pressing the space bar or tapping your phone or mobile device. I'll give you a moment to do that right now. Okay, now that you've worked out the problem. Okay, so Becky works 40 hours. So we see over here on-site technical support is 1/8 of her total time. So 40 times 1/8 is equal to 40 divided by 8, which is 40 times 1 divided by 8. 40 divided by 8 equals 5. So 5 of those hours would be devoted to technical support. This is just an aside. This didn't fit anywhere else, but this is a tricky thing they do on the test sometimes. You can't round up real things. So this is related to inequalities, but not really. Say a baggage screener has to inspect every 9th item. After 250 items, how many will be inspected? You divide 250 by 7, you get 27.777. You don't round that up because you can't inspect 3/4 of an item. So 27 items were inspected. Okay? A lot of times you can't round up real items. Just keep that in mind. Functions. In a function, you plug in the number like a substitution. Function of x equals x plus 5. Find function of 37. The answer is 42. So a function takes an input and returns an output. You can recognize a function in a table or graph by determining whether or not there is only one output value for each input value. This is very important. Function has only one output for each input value. What this means is, given a chart, there shouldn't be multiple identical x input values, though there can be identical y output values. So on the right, I show an example of what's a function and what's not a function. This isn't really that clear without graphing them, but the test doesn't go that in depth, and I don't really want to confuse anyone. So what happens is, look at the graph over on the far right, up top, the top right. See how we have 1, 2, 3, 4, 5, 6, 7 different x values. Now, the y values, some of the y values are the same, but the x values aren't. The reason why is, if you input any number, say you input a 2. If you input a 2 to any function, like a function could be an equation, like we have over on the second line, function of x equals x plus 5. But for a function to be a function, the input, when you put the input into the equation, can only return one value. So what that means mathematically is, when you input a value, you can't have two different values. An example of something not a function shows this. At the bottom of the page, when I input 1, right, it returns 3 and 5. Now, if you think about this in terms of mathematics, a function, it's basically me inputting the same number for x and getting two different outputs. So if I input f of x and I have whatever this function is, I'm not going to illustrate it. It doesn't matter. But if I input 1 and get two different answers, it's not a function. The graph will look like that. Okay? Now remember, you can have the outputs can be the same for different inputs, but you can't have multiple outputs for the same input. You can have the same output for different input, but you can't have different output for the same input. I know it's a little confusing, but look at the graphs. It'll make a little more sense.